For question number 9 on the midterm paper, we were told to prove that cos of x divided by 1 minus tangent of x plus sin of x divided by 1 minus cotangent of x is equals to sin of x plus cos of x. So for these kinds of trigonometric identities that we are told to prove, we normally take the most complicated part and try to simplify it and try to show that it's equals to the least complicated part. So we're going to take the left hand side and work on the left hand side to see if we have sin x plus cos x. So let's begin. We have cos x divided by 1 minus tangent x. But before we begin, I want you to note two things. I want you to first note that tangent of x is sin of x divided by cos of x, and cotangent of x is equals to cos of x divided by sin of x. These two identities are called quotient identity because they are formed by dividing two trig functions. So quotient identity, remember. Now we move on to prove this. So we will substitute. We have cos of x divided by 1 minus. So substitute tangent of x, we have sin x divided by cos x. For tangent of x, we substitute sin x divided by cos of x plus this how we have sin of x all divided by 1 minus cotangent will give us cos x over sin x. We want to prove as to whether it's equal to this side of the equation. Great. Here, this is a complex fraction. We can find the least common denominator here. So we have cos x divided by, now this times 1 is cos x minus sin x all divided by cos x plus the very same thing here. You have sin of x all divided by sin x times 1 is sin x minus cos x all divided by sin x, and this we want to know as to whether it's equal to this side. Once we do that, we can simplify this side. Say there is a greatest division bar, and this expression is 400 cos of x. This cos of x is going to go to the numerator and be multiplied by cos of x. So we have this times this, we have cos square x all divided by cos x minus sin x, and we have plus. A very same thing happens here. So this sin x goes up, it becomes sin square x all divided by sin of x minus cos of x, and the entire expression want to know as to whether it is equal to sin x plus cos x. Great. So to simplify this side, we see that the denominator here is cos x minus sin x, and here is sin x minus cos x. So the only difference here is a factor of -1. So we have cos square x all divided by cos x minus sin x plus sin square x all divided by, in this case now we'll factor out -1 here. So if we factor out a -1, we have cos of x will become positive. So we have cos x, then the sin of x will become negative minus sin x. We want to know as to whether it's equal to the expression here. So -1 times cos x will give you negative cos x, and -1 times negative sin x will give you positive sin x. So this entire thing will imply that we have cos square x all divided by cos x minus sin x. Now this negative will affect the numerator here, which is the coefficient of sin square. So you have minus sin square x all divided by cos x minus sin x. And we want to know as to whether it is equal to sin x plus cos x. So once we have this, we can take one of the denominator and subtract the numerator. So we have cos square x minus sin square x all divided by cos x minus sin x, because the denominators are now the same. So remember, difference of two squares. Cos square x minus sin square x is cos x plus sin x, cos x minus sin x. So we have cos x plus sin x times cos x minus sin x all divided by cos x minus sin x. And we want to know as to whether it's equal to this. So once we do that, what we observe is that the expression here is going to cancel out the expression here, and we're going to have only cos x plus sin x Therefore, the entire expression here simplifies to cos x plus sin x, and it's equals to sin x plus cos x. And this is the end of the proof. Thank you very much, and we hope this video was helpful to you. See you in the next video where we solve question number 10, and that's the end of this series.